Dear students, today I am going to explain about algorithms for relational database schema design. There are different algorithms for relational database schema design. Now we are going to see one by one. First algorithm is for relational synthesis into third normal form 3NF with dependency preservation. Dependency preservation and lossless join are the important properties of decomposition. So now we are going to see the algorithm for dependency preservation. That is relational synthesis into 3NF third normal form with dependency preservation. For this, this algorithm is otherwise called as relational synthesis algorithm. Input for this algorithm is the universal relation R along with that set of functional dependencies F on the attributes of R. If any relation will take, there will be set of attributes and set of functional dependencies. That should be given as an input to this algorithm. The first step is should find the minimal cover G for F. Already we have discussed about how to find out minimal cover. So first step is find out the minimal cover G for the given set of functional dependencies F. Second step is for each left hand side X of functional dependency that appears in G, create a relation schema in D with attributes X union. So that is union, that is A1, A2, etc. AK. That means attributes 1, attribute 2, etc. AK. Where X defines A1, X defines A2, etc. X defines AK are the only dependencies in G with X as left hand side. X should be there in the left hand side, okay, of the functional dependency. Place any remaining attributes in a relation schema to ensure the attribute preservation property. Okay. So here the main thing is every relation schema created by this algorithm is in 3NF. This above algorithm is in 3NF. Okay. The main aim is relational synthesis into 3NF only with dependency preservation. So that this is the claim we can make it. Every relation schema created by this relational synthesis algorithm is in 3NF. The next algorithm is relational synthesis into 3NF with dependency preservation and lossless join property. The previous algorithm is only converting relational synthesis into 3NF with dependency preservation. This with dependency preservation and lossless join property. So the input for this algorithm is same, the universal relation R with functional dependency F and attribute set of R. Okay. Find first step is same thing, find a minimal cover G for F, and the second step is same thing for each left hand side X of functional dependency that appears in G, create a relation schema D with the attributes X union A1 union A2 etc. AK, where X defines A1 comma X defines A2 etc. X defines AK are the only dependencies in G with X as left hand side relation. So this is the second step. The third step is if none of the relation schemas in D contains a key of R, then create one more relation schema in D that contains attributes that form a key of R. This is an additional step we are adding in that algorithm, the relational synthesis algorithm, to preserve the lossless join property. It should not lose any attributes or any thing in the output. So that preserving that one, this additional step is added. The next thing is algorithm for we are using algorithm to finding a key K for R. K key name is called as key K and the relation name is called as R for a given set F of functional dependencies. Okay. So that is the thing. What is the input we are going to give for this algorithm is a universal relation R and a set of functional dependencies F on the attributes of R. All algorithms the input is same. The universal relation R and set of functional dependencies F on the attributes of R. So first what we are going to do, it means set K equal to R. R itself assigned to K for each attribute A in K. Each and every attribute A in K, we have to compute K minus A plus attribute closure with respect to F. Then if K minus A plus contains all the attributes in R, then set K is equal to K minus that A, that will be assigned as a key attribute. Okay. So these are the three different algorithms 11.2 and 3 different algorithms used for finding the used in relational database schema design. Then another algorithm used is relational decomposition into BCNF with lossless join property. This remaining algorithms we have seen relational decomposition 3NF, relational synthesis into 3NF with dependency preservation and 3NF with dependency preservation and lossless join property. This is relational decomposition into 3BCNF with lossless join property. For this also input is same, universal relation R and a set of functional dependencies F and the attributes R. First initially D is equal to R, that will be assigned, while there is a relation schema Q in D that is not in BCNF. What we have to do? Choose a relation schema Q in D that is not in BCNF, that is the first step. Then find the functional dependency X defines Y in Q that violates BCNF, that is the thing. Then replace Q in D by two relation schemas Q minus Y and X union Y. Okay, this is a step for finding the BCNF, that is relational decomposition into BCNF. Here also there is no lossless join property, lossless, okay, because that is a main property that each and every relation schema has to satisfy lossless join and dependency preservation. So for that purpose this algorithm is used. Okay, so please go through these algorithms. One is relational decomposition, that is relational synthesis into 3NF with dependency preservation. Next one is relational synthesis into 3NF with dependency preservation and lossless join property. Another one is relational decomposition into BCNF with lossless join property. The last one is finding a key K for a given set of set F of functional dependencies. So please go through these algorithms. So each and everything is important for your exam.